So children, in the previous class we had studied about 4 algebraic identities. First one is a plus b whole square, that is equal to a square plus 2ab plus b square. Second is a minus b whole square, that is a square minus 2ab plus b square. Third one is a plus b into a minus b, which is equal to a square minus b square, and the fourth one is x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. Now children, I have told you that these identities can be used in two different ways. One is for expansion of the given expression, and second is for factorization of the given expression. In the previous class, we had learnt how to expand the given expression. It means in the first identity, if the question is given in this form, a plus b whole square, then the expanded form will be a square plus 2ab plus b square. Whereas, if the expression is given in this form, a square plus 2ab plus b square, and you are asked to factorize it, then you can write it in the form of a plus b whole square, which is actually equal to a plus b into a plus b. Now let us take for example, suppose I say x square plus 10x plus 25. If this is an expression, let us see this is already given in the expanded form. I think by looking at the expression you can easily make out whether it is given in the expanded form or it is given in the factorized form. As I told you earlier, if it is given in terms of the product of two factors, then you can say it is the factorized form. But here in this given expression, this is the expanded form given, it is not in the factorized form. And now my question is, factorize the expression x square plus 10x plus 25. First thing we'll look for is, if you look at the identity a plus b whole square carefully, the expanded form, you can see that in this identity there are two terms, a square plus b square. It means if there are three terms in the entire expression, out of those three terms, two terms must be perfect squares, like here a square and b square. And then we'll look at the middle term. Now look at this expression, given expression. Look at this first term, it is a perfect square, it can be written as x whole square, and 25 can be written as 5 whole square. So let me write it in that format, x square plus, let's leave the middle term as it is, and 25 can be written as 5 square. Now I have to check out, is the middle term also in this format of 2ab? Because now you have chosen your a and b in the question. Your a will be x and b will be 5. So now let me check out, is the middle term also in that format? I will write 2 into a into b. What is a in this case? X, and b is 5. So if I multiply these three, am I getting 10x? Yes, I am getting 10x. It means that this expression is exactly in the format of the identity a plus b whole square. So what can I do? I can write this expression as a plus b whole square. In place of a, I will be writing x. In place of b, I will be writing 5. So x plus 5 whole square, or I can write it as x plus 5 into x plus 5. This is the factorized form of the given expression by using the first identity. Suppose I take one more example. Say I take 4y square plus, I will use the first identity only in this case, plus 25 20y. Okay, this is the question now. Now in this question, tell me, which identity do you think we can use? Again, you can think of using a plus b whole square, but before we use that identity, first we must make sure that two terms must be perfect squares. Okay, in this case it is 4y square. 4 is also a perfect square. 4y square can be written as 2 square y square, or I can write it as 2y whole square. So in place of 4y square, I can write 2y whole square. When I open out 2y whole square, I will get 4y square only. Similarly, I can write 25 as 5 whole square. So now I have two terms which are perfect squares. So in this case, my a will be 2y and b will be 5. I just need to check out, is the middle term also in the form of 2ab or not. So it is, let me write it as 2ab, 2 into a is 2y, so I will write 2y here. B is 5, so I will write 5 here. After writing it in the form of 2ab, multiply it and check whether are you getting this term or not. 2 into 2, 4, 4 into 5 is 20. Why? Exactly, we are getting that term. It means that this expression is exactly following the format of a square plus 2ab plus b square. So, if the expression is given in this form, we can always write it in the form of a plus b whole square. So, in this case, what is a plus b whole square? A will be 2y, b will be 5. So, 2y plus 5 whole square. Take one more example. Suppose now I take 16 p square plus, let me take here 64, okay, 32p. Suppose this is my question now. Or should I change the sign this time? Just let's use the second identity now. I am putting here minus sign. In the identity a plus b whole square and a minus b whole square, there is not much of a difference. There is only difference of minus sign at one point, and that is before 2ab. That's it. Rest the entire procedure will be same. So here 16p square can be written as 4p whole square. We will not touch the middle term in the beginning. First we write the perfect square terms so that we can find out our a and b conveniently. 64 is the square of 8. Now let us check out. So what is your a according to this? It should be 4p and b should be 8. Let me check out, is the middle term in the form of 2 into a into b. A is 4p and b is 8. And now let's check out whether it is giving us 32p or not. 2 into 4 is 8. 8 into 8 is 64. Sorry, I gave you a wrong question. Let me make it 64 here. Okay, because I created the question on my own. So it's 64p. Okay, 2 4s are 8, 8 8 is 64p. Yes, it is satisfying. Hence, we can use the identity a minus b whole square, and I will be writing it as 4p minus 8 whole square. Had I written here 32p, then you would not have used the identity a minus b whole square, because even though you have a square plus b square in the expression, but the middle term was not exactly following the pattern of 2ab. Hence, you would not have used the identity in that case. Okay, but right now I have corrected it. I have made it 64p. So you can use the identity a minus b whole square. One more example before I move on to the next identity, a square minus b square. Now suppose I take 225x square plus 60x plus 4. Okay. Now again we have to look for whether we have two perfect square terms or not. 225 is the square of 15, you all know that. So I can write it as 15x whole square. 4 is the square of 2. So we have two perfect squares. Now check out for the middle term. 2 into, what is your a in this case? 15x, and what is your b? 2. So 2 into 15x into 2 will give you the middle term as 60x. 15 to the 30, 30 to the 60, 60x. So I can write it as 15x plus 2 whole square. So this is the factorization of the given expression. Now suppose I say 225x square minus 64y square. So now can we use a plus b whole square or a minus b whole square? No. Please don't think it is minus sign and square, so it is resembling a minus b whole square. There is a difference in a minus b whole square and a square minus b square. These two are not the same. Okay, so here the given expression is resembling this identity a square minus b square. But again, the requirement is the same. We need to write both the expressions in the form of perfect squares. 15x whole square minus 8y whole square. So now it is in the form of a square minus b square, with what is a in this case? 15x, and with your b as 8y. So what is the identity for a square minus b square? It is a plus b into a minus b. So your a is 15x plus b, which is 8y. The second bracket will be a minus b, that is 15x minus 8y. Let's take another example based on the same identity. Suppose I write x square minus y square upon 100. Again, this resembles the identity a square minus b square. But first thing is that you must write them in the perfect square form, both the terms. In this case, first term is already in the perfect square form, x square will remain x square only. But here, y square upon 100. I need to take 100 also in the bracket. Okay, so it will become y upon 10 and then whole square. So that when I open it out, it will become y upon 10 into y upon 10, which will give me y square upon 100. So what is your a in this case? X, b is y upon 10. So when I apply the identity a plus b into a minus b, I will get a which is x in this case, plus b which is y upon 10. Second bracket is a minus b. So a is x minus b is y upon 10. So this is the factorized form of the given expression. Let's take one more example. Say if I take 4y square minus 4y plus 1. Now this is not on the identity a square minus b square, but I am just taking it, it's a question from your NCERT only. So what does it resemble according to you? It resembles the identity a minus b whole square, but without checking you can't say it. For that we need to first check out. The first term can be written as 2y whole square, 1 can always be written as 1 square, and the middle term, there is a minus sign, minus 2 into what is your a, that is 2y, what is your b, that is 1. Are we getting 4y after multiplying this? Yes. It means it is exactly following the pattern of a minus b whole square, which is a square minus 2ab plus b square. So I can write this in the factorized form as 2y minus 1 whole square, that is a minus b whole square, which in turn can also be written as 2y minus 1 into 2y minus 1. So I can say these are the two factors of the given polynomial, quadratic polynomial. Okay. So in this way you can complete your question number 3 of your NCERT book. There are only 3 parts, out of which 2 I have already discussed. One part you can do on your own. And the fourth identity, x plus a into x plus b, factorization, actually that is similar to splitting the middle term. When I write x plus a into x plus b is equal to x square plus a plus b into x plus ab. So as I told you, you write the middle term as the sum of two numbers, and the same two numbers, their product should be written here. So it's exactly the middle term splitting, which we have already covered in exercise 2.4 question number 4. That was splitting the middle term. Basically we used this identity only. So either you use the identity or you directly split the middle term, is one and the same thing. So I am not doing any more questions on this. We have already discussed this part. Now 4 identities are clear, the expansion as well as the factorization. Now the fifth identity I am using, that is your a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This is the identity a plus b plus c whole square. So when you expand it, you will get this. If the expression is given in this form, a plus b plus c whole square, you can write the expanded form in the form of right hand side. If the expression is given in the right hand side form like this expression, you can shift it to a plus b plus c whole square, which is the factorized form. Let's do it with the help of an example. Say I take 2x plus 3y plus 4z, right? And right now I am taking all positive signs, but here there can be any sign, not necessarily plus signs always. So let me first start with the plus sign only. So in this case, you can match it with the given identity a, b, c. So your a will be 2x, b will be 3y, and c will be 4z. Now I have to write the expanded form of this. So first I will write a square. Though if I write 2x square, it will be wrong. As I told you yesterday also, it has to be 2x whole square. Similarly, b square will be 3y whole square. C square will be 4z whole square plus 2 into a into b. Your a in this case is 2x and b is 3y. So I will write 2 into a into b. Next term is 2bc. So 2 into b into c. What is your b? 3y, and c is 4z, plus 2 into c into a. c is 4z and a is 2x. First, what we have done, we have simply substituted the values of a, b and c in the given expression. Now let's simplify it. I will get 4x square plus 9y square plus 16z square plus, now I need to multiply these three. 2 into 2, 4, 4 into 3 is 12, and then x into y. So 12xy plus 2 into 3, 6, 6 into 4 is 24, and then y and z. So yz plus 2 into 4 is 8, 8 into 2 is 16 zx. So this is the expanded form of the given expression. Very simple. Now let me take one example with some of the negative terms. Suppose I take a number as x minus 2y plus say 3z whole square. First, I will express this expression as a plus b plus c whole square. So how will I write that? I will say it is x plus, I need all plus signs in between a, b and c. So what will I do? I will take minus 2y in the bracket plus 3z. Okay. So this is your a, this is your b, and this is your c. A will be x, b will be minus 2y, c will be 3z. Now what is the expanded form? First I will write a square, that means x square plus b square, which will be minus 2y whole square, plus c square, which is 3z whole square, plus 2 into a into b. A is x, b is minus 2y, plus next term is 2bc, 2 into b into c, plus 2 into ca, that is 3z into x. Now when you open out the brackets, negative signs will automatically reflect wherever required. So this will become x square. Now minus 2y whole square will become plus 4y square. This much I hope all of you understand. Whenever there is an even power on the negative sign, we get it to be positive. Plus 3z whole square will be 9z square. Now look at the fourth term. It is minus sign here and no other minus sign is there, so definitely this answer will be in minus. 2 into 2, 4, and then x and y. Similarly here, 2 2s are 4, 4 3s are 12 with one minus sign. So minus 12yz plus 2 into 3 is 6zx. So this is the expanded form of the given expression. Let's take one more example with negative signs. Say I get 2x minus y minus z whole square. Then I will be first writing it as 2x plus minus y plus minus z. Okay, so that we can express it in the form of a plus b plus c, where what is your a? 2x, b is minus y, C is minus Z. So using the identity, I will get 2x whole square plus minus y whole square plus minus z whole square plus 2 into a into b plus 2 into b into c plus 2 into c into a. So that gives me 4x square minus y whole square will be plus y square minus z whole square will be plus z square. Now when I simplify this term, I will get 4xy with a negative sign. So minus 4xy. Here minus and minus will become plus. So I will be left with 2yz. Here this will be minus 4xz. That is the expansion of this term. Alright. Or last example, let me take, say minus root 2x plus y plus 3 root 2z whole square. Suppose this is the expression. There can be any real numbers as the coefficients of x, y and z, or in place of x, y, z also we can have any variables. I can use a, b, c, p, q, r, x, y, z, anything can be there. You just have to follow the pattern of the identity a plus b plus c whole square. So what can you write this as? Minus root 2x plus y plus 3 root 2z whole square. So this is my a, this is b and this is c. So when I open it, I will get a square plus b square plus c square plus 2 into a into b plus 2 into b into c plus 2 into c into a. Right? First put the values correctly in the given expression and then simplify. Minus or upper whole square, so minus will vanish. Root 2 whole square will be 2 and then x square plus y square. Now here it is 3 root 2z whole square. So z square will be z square only, but 3 root 2 whole square will be what? 3 root 2 into 3 root 2. That gives you 3 into 3 is 9 and root 2 into root 2 will give you 2. 9 into 2 is 18. So it is plus 18z square. You should do it like this. Whenever you get some complicated expression, first solve it in rough carefully, then write down the expression. Then there is one minus sign here. So minus 2 root 2 xy plus, now here if you multiply, this is 2 into 3 6 and then root 2. So we will write 6 root 2 and then yz and then minus 2 into 3 is 6, root 2 into root 2 will give you 2. 6 into 2 gives you 12. So 12zx. So this is the expansion of the given expression. So I hope you have understood using the identity a plus b plus c whole square how to expand. Now we will learn how to do the factorization by using this identity. Okay, let's take one example. Say factorize 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now you can see there are some negative signs as well, but right now we are not going to do anything with the negative signs. Let's first write them in that format of the identity a plus b plus c whole square is equal to what? Let me just write it here so that you can compare it with the identity. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. We need to check out whether the given expression is exactly of this format or not. So in place of a square, what can I write? 2x whole square, because 4x square can be written as 2x whole square. So our a will be 2x. Similarly, in place of b square, I can write 3y whole square. So our b in this case will be 3y plus c square can be written as 4z whole square. So my c will be 4z in this case. So you should be very clear about a, b and c plus 2 And now you just keep on following this pattern of the identity. 2 into A into B. Later on we'll check out whether it is matching with these terms or not. Okay. After getting ABC, now you know what is 2 into A into B. In place of A I will be writing 2x. In place of B I will be writing 3y. Similarly, plus 2 into B into C, that is 4z, plus 2 into C into A. Now still it is not complete because we have negative signs also. Now look at the expression carefully. Which two terms are having negative signs? These are the two terms. In these two terms, which are the variables used? Y and z. Here it is x and z. That means z is common in both the terms. It means that the term containing z should be a negative term. So out of the three terms, 2x, 3y and 4z, I will be putting negative sign along with 4z. Okay. So wherever you find 4z, put a negative sign. Okay. So what is our A, B and C in this case? Now A will be 2x, B will be 3y and C would be minus 4z. Minus. So minus sign automatically we have introduced here. Initially don't bother about the minus signs. First write everything in positive. Then see which two terms are having negative sign and look for the common variable. It means the term containing z should be negative, which is this term. So 4z. Wherever you find 4z, you put a negative sign. So it means the entire given expression is in this format. A square plus B square plus C square plus 2AB plus 2BCN plus 2CA. So can we write it in the form of A plus B plus C whole square? So this expression, when I write in the form of A plus B plus C whole square, it will come out to be 2x plus 3y plus minus 4z. Let's put a curly bracket here, whole square. Or I can write it as 2x plus 3y, plus minus will become minus, so minus 4z whole square. Or we can write it as 2x plus 3y minus 4z into 2x plus 3y minus 4z. So this is the factorization of the given algebraic expression. Okay. Now let's do the one more question from your NCERT book. This is question number 5, second part of your NCERT book. The moment you see there are so many terms, you can immediately come to know that we are going to use the identity A plus B plus C whole square. But for that, we first have to arrange the pattern according to the identity. So what is your A square? Can I write it as 2x whole square? That would be wrong, because if I write 2x whole square and you open it, it will come out to be 4x square, not 2x square. So in order to get 2 here, what should I write in this here? Can I write root 2 x whole square? Now when I open out root 2x whole square, it will come out to be root 2x into root 2x, which will give you 2x square. Okay. Similarly, y can be written as y square, and 8. Again, 8 is not a square of any number. So can I write this as root 8z whole square? Whenever you find a number which is not a perfect square, put a root on that number and then you write it as whole square. Again, as I told you, don't bother about the negative signs in the beginning. First, keep on writing everything with a plus sign. Plus 2 into A into B, that is root 2x into y, plus 2 into B into C, plus 2 into C into A. Alright. Now we have to see where should I put the negative sign. That is important. Now look at the two terms which are carrying negative signs. One is this, another is this. Those are negative terms we have underlined. And then we see which is the common variable. Here the variables used are x and y. Here x and z. It means x variable is common in both. That means the term containing x should be negative. And that is the first term. So what will I do? I will put a negative sign everywhere wherever you see this x. So minus root 2x. Here also I will put minus root 2x. And here also I will put minus root 2x. x. Okay. Now let's check out whether all the terms are matching with the given expression or not. A square, b square, c square are clear. Now look at this expression. Is it matching with this expression or not? Here there is a minus sign, 2 into root 2, 2 into root 2 xy. So this term is exactly matching with this term, no problems. Look at this term. Is it matching with this term or not? Y and z are there, y and z are there. 2 into root 8. Here you are getting 4 root 2 and here you are getting 2 into root 8. 2 into root 8, if you simplify, you will write 2 into 8 is what? 2 into 2 into 2. So if I write it in the simplified form, this 2 can be taken out. So ultimately it will come out to be 4 root 2 only. Okay. Similarly, the last one, x and z are there, minus sign is there, so minus sign is there also. Now here they are getting 8, but here you have 2 into root 8 into root 2. 2 into root 8 into root 2, and you have to see whether you get 8 after multiplying or not. So 2 into under root, 8 to the 16, which will give you 4, which is equal to 8. So ultimately it means we are getting all the required terms of the expression in the same format of the identity. So what is our a in this case? A would be minus root 2x, b will be y, and c would be root 8z. Okay, if you want, you can write root 8z. Root 8 you can write in the simplified form as 2 root 2z. So the factorization will be, this is a plus b plus c whole square. Alright.